guys, to celebrate 80,000 subscribers, let's talk about something cool today. Let's talk about the Tesla powertrain and specifically the inverter. Kind of late today. The sun is already down, and that's because I just was running around all day today and I wasn't able to actually sit here and do it. Also, I want to do some reading before because there were some things that I didn't know. Michael and the guys over at EV West last week, they took one apart. As you know, they are getting these as a steady stream now. You know, they have a few of them. They have a few coming on the way. They've taken the first one apart and they recorded it for me. I wasn't able to be down there last week because I have some stuff up here, but they sent me the video. What an amazing thing of technology this is, right? It's roughly the size of a basketball, but it outputs well over 400 kilowatts of power, which is pretty amazing. Two of these would pretty much make a hypercar. And once you see how they constructed and designed it, it's gonna blow your mind away. Okay, let me start by saying that this video is going to be about the basic concepts. I'm not an expert in any of these fields, right? I have zero training in electrical engineering. I'm able to grasp some of the basic concepts, which I am now gonna share with you. So let's roll the video. As you can see, these guys here are taking it apart, and the reason why these guys are taking this apart is because we intend to use these. Before we can do that, we have to get the inverter working with the motor, and to do that we have to do a little bit of hacking. So let's look at how these things are put together. This is actually a pretty simple device, right? It's what's known as a three-phase speed controller, and it's a switching mode speed controller. Looking at a very popular topology of this, you will see that it's a very simple device. It just has 6 switches. So the B plus and B minus, battery plus and battery minus, have a way to access any of the 3 phases. So this design calls for 6 switches, and there are 2 switches for phase. So there are 3 phases. This is like kind of a triangular thing once you take the cover off. Here's how these devices are put together, right? There are the switching section. This is the power section of this inverter. This is the thing that has some kind of semiconductor or transistor, large format transistor that can carry all that current, and it's to turn the phases on and off. That section has some capacitance devices, right? It's got like film capacitors or whatever, just to be able to handle some of the ripple and the currents in there, and so those are probably going to be kind of large and stuff. And then going back in the chain, now there's going to be another circuit that's going to be the gate driver, and those are essentially just an amplifier. It takes a low-level signal and it amplifies it to a power level high enough for these power section to be able to recognize it, and then, you know, furthermore amplify it into the motor phases, right? And so there's that gate driver system. And then going back, you get into the logic board. And the logic board is essentially, it's an advanced circuit that has microcontrollers that then do all kinds of things, right? This section right here is the one that decides what to do with all the inputs. This section is the one that has sensors throughout the system, right? It has temperature sensors in the motor, temperature sensors on the actual controller, on the power section, right? To monitor temperature. Oh, it has a signal from an encoder on the shaft of the motor because it wants to know what the motor is doing. If it indeed is spinning, if it's spinning in the right direction, if it's spinning at the right speed. And so this logic section is what decides what to do with all that information. It runs functions that are programmed in its memory to be able to do stuff. And essentially what you are telling this thing through a throttle input is tell it how fast to spin and with what kind of torque. This is the brains of the controller, and so in order to have this thing running, well, you need this brain to work. And the problem with that, of course, is that the manufacturers do proprietary software on this piece of hardware, right? This brain is made of microcontrollers programmed at the factory, and they are programmed with software, but that software is closed up. It's not available for the public. So there's only really two ways of getting this system up and running. You either have to get rid of the logic board that has a closed system, design another open source or something that you can program and stuff, and then install it in its place, and then you have access, right? You control the brains because it's your brain. Or what you have to do is you have to read the communication that goes in and out of the brain with the other systems in the car. And then once you recognize and isolate the commands that are going in between, then you can, you can develop another system that speaks that same language and then spits those out, those commands, and then essentially tricking this brain into thinking that it's in the original car and it's getting the right commands from the right devices that it needs, and you trick it into spinning the motor and just working for you, right? So there's those two ways of doing it. And so of course there's another team in the internet that is doing just that. It's trying to hack the communication, run over by a guy, Colin Kidder, and they're actually spinning motors. And so they actually cracked, except though they're finding out is that, well, the software often changes with the manufacturer, right? And so that's the problem that I see with that system. Every iteration of the software, the commands might be completely different. And so what one might work, and it doesn't work for the other. The other way, the way that EV West is going to do it is by completely replacing the brain, because then you can control exactly what's designed into that brain. And so you have the power. There's no surprises. With one system, it's going to work. With the other ones, as long as the hardware is the same, it's going to work. And that's usually manufacturing dictates that it's easier to change software than it is to change hardware. And so the hardware tends to stay the same for longer periods of time. So the drivetrains will change, and componentry, it's going to change. But of course, the cycles are a bit longer than the software ones, right? So while looking at this video, I started also doing some research. Look at these. This is some kind of goo that the IGBTs are encased in. Of course, this is probably for thermal management. It's probably for protecting them against shock, right? Because this is in a place in a car that's a lot of vibrations and stuff. So maybe that gel is to protect them. And here is the interesting thing. There's no large format IGBT modules. This controller uses discrete TO247 package, right? For those of you who don't know, so an IGBT looks like this. It's a big boxy thing. There's two large format transistors in here, right? And so the manufacturers, I think, put a bunch of little ones in there, or I don't know, they do something to be able to handle a lot of power. Typically, this is what you have to use these days if you want high power output, right? And so it is very surprising to see that the Tesla inverter does not have this large semiconductor modules. What they are using something like this. TO247, I think this is a smaller one, but it's roughly around the same size. And what it does, it just uses a bunch of these in parallel. In fact, it uses about 14 of these IGBTs in parallel per switch. So there's 6 switches, 6 times 14, that's 84 total IGBTs. And 14 of these will actually handle the 1500 peak amps that this motor system is able to produce. It's pretty crazy. Of course, that shouldn't come as a surprise to me. Here's essentially what happened. These guys made a car that competes with supercars, and they did it using no custom parts. I mean, like the batteries were already done. They were laptop batteries. They used a motor that is nothing special. It's just they did some clever things into cooling it, and it turns out they didn't even use any specialized semiconductors. They used just regular off-the-shelf transistors. I mean, this is the stuff that you find on like large audio amplifiers. You know what I mean? Like this is crazy. So this is very well on their way now that we have and removed the logic board from this. It's going to be replaced with an open source logic board. that has the brains, and it's got a USB connection to it, and you'll be able to, you know, program it and change it and do all this other stuff. And pretty soon, next thing is figuring just the mechanicals, how to fit one of those into a VW bus. Or why? Just because I hope I helped you understand a little bit more Tesla's controller works, some of the basic principles. And next time I talk about one, hopefully is gonna be one that is already working. All right, guys, thank you for watching this video. As always, make sure you guys check out my Patreon. Remember, I don't get paid much for these videos from YouTube, so if you want to support me, Patreon is really a good way to do it. Otherwise, please share and like this video, and if you have any questions, put them in the comments. See you in the next video. All right, thanks, bye.